Here's our Tektronix 5223. This is a hybrid scope, which means it's an analog scope when you want it to be, and it can also be a digital scope. It has a digitizing time base, the 5B25N. And I'm going to give it to somebody. Before I give it to somebody, I need to make sure that it meets my standards. I wouldn't want to give it to somebody if I wouldn't use it myself. So it works just fine. It works in the middle channel, in the middle slot. Okay, so this is just our calibration voltage coming in, and the other vertical compartment works fine. So now we're triggering on our left compartment, and you'll see the trace comes up fine. Problem is, when I put in my 5A48 in either of these slots, you get the following. In my other scope, it wouldn't even let the scope turn on. So stick it in this, and we get a single dot in the middle of the screen. So I'm going to figure that out, and there's probably something rather broken in here. I bet you it's like a capacitor that's gone out of value. The tantalums seem very blamable. They do have these blue tantalums here, so we'll take a look at those. And then we also have this skirt on the volts per division knob. And here's another problem. Here's the first 5A48 vertical amp, and you see we go through all the amplification, attenuation. So we cycle through that. Here it goes, is basically AC coupled. So there's probably something we have to shoot with contact cleaner, because the signal's not getting through. You get the big spikies, and anything below here basically means it's getting AC coupled in. Alright, so now on to the other 5A48. Okay, so we have these tantalums. We'll put it up on the curve tracer. This is our curve tracer. So when we short it out, it gives us a straight up and down line like that, and the capacitor gives us an ellipse. So we have this tantalum. I already took a look at these, so I'll just show you my findings. We have this tantalum. Okay, so it gives us an ellipse, and you can notice that the ellipse kind of is skewed. It's skewed, and the skew to the ellipse kind of being rotated like that suggests that it has a resistive component in there. So you can imagine an ellipse kind of being added on top of a resistor, and what I mean, the ellipse from a capacitor being added to the straight line from a resistor. Well, what might that look like? It will look like an ellipse that's skewed off, just like we have here. So this should be it will be okay. And then we put this one up, and we see that it's a dead short. There is no redemption from this capacitor, so I'm going to bet that it's this capacitor that was basically screwing everything up. Kind of thumbing through here, I think a 10 microfarad cap would be a suitable replacement. You gotta watch out because, well, you might have a stripe on the tantalum capacitor. It has a different, I guess, standard for marking. We get our electrolytic out, and the stripe obviously has a negative sign on it. That means that's the negative side. Where you see the stripe on electrolytic, that's where the negative is. You get the tantalum out, and you see the stripe, and here's the positive side. Now we have to fix that issue with the broken skirt, and we're going to get our crazy glue out and crazy glue it back. There's our skirt. Yes, I did just pull out a mini clamp. We'll get a mini clamp put on this dial. Okay, so we put a 300 millivolt signal, this is from the calibrator, on the first channel, and that comes up just nice. That's normal. The other channel 2, we have some action here, putting it through its range, so that's in the 2 volts per division. We'll apply a signal. Okay, so the signal comes through. So this is just the this is probably just the offset that's all screwed up. 1, 2, 3, 1, 2, 3, 1, 2, 3, 2, 3. So I'm going to have a look at the step balance attenuation. How about I do this? How about I just run the contact cleaner through the switches just like we did with, I think it was this one, and then see if this issue clears up. Does the position control work? Okay, so the position control works. See that? One, two, three, 1, 2, 3, 1, 2, 3. That's interesting. So we're going to have a look at there are a couple of potentiometers that kind of adjust between the balance, the DC balance for each of these little settings. So I think the DC balance is just off. So now we'll have access to total with those balance potentiometers in here. We're going to hook on to test point 1 and test point 2 right here, and we're going to check, see if they're 7 volts. So there's 7.4. Oh, it needs to be 7.5 volts. So here's 7.4. That looks to be okay, and that's for channel 1. And we'll see the test point for channel 2. And we have 7.56. So that's kind of in the ballpark. I'm not too worried about that. So while the first channel is high up there and it's inside the scope and it's really protected, here we have the second channel, and you know, they put all these ventilation holes. I don't see what else they would have been for, all these ventilation holes in the bottom. And we have the ingress of dust through these tab, I guess, slots. These slots made for for the mounting tabs. Have the ingress of dust in there, and it just worked away at the switches. This is what the variable attenuator does. It's kind of scratchy, but you see how the bottom, the 0, stays in place? Okay, so we go to our channel 2, put a signal on here, trigger on channel 2, and our 0 is right here. Wonderful. But take it out of cal, and that 0 does not stay in place. Well, I figured I'd take a look at the capacitors in this one. Does lightning strike twice in the same place? Well, tantalum capacitors are not lightning. Tantalum capacitors, oh, you see those gobs of whatever metal that were on there. Tantalum capacitors in the same place are going to go bad. We're going to take this one, which is bad, and compare it to the good one. And we're going to do that on the curve tracer. So I've been going down and testing all these curves. I guess I could show you an example. We have these back-to-back pair of transistors. So that's 1, 2, 3, and that's on the bad one. 1, 2, 3. So they look the same. You do that for a bunch of different sections, and I was looking to find what the differences were. And I come over here, and I'm looking at this potentiometer because I wanted to test it, and I see, oh, wait a second. So this is the bad channel 2, remember? This is the bad channel 2, and here we have on the step attenuation balance a lead that was maybe priorly soldered on but has come undone. One connection made the entire thing not work. And we can uncalibrate it. Maybe I'll have to take a look at that. Maybe we're AC coupling. No, we're not. I think we're going to have to twiddle around with some of the adjustments, but looky there, that's all fixed up, and I'll get it to that high school kid shortly. Get him this oscilloscope. Here we have to adjust the step attenuation balance, and there's a specific way you do that. So here we have our attenuation or amplification, either way you look at it. One is just the inverse of the other. Of our 1 millivolt and 2 millivolt setting, 1 millivolt per division, 2 millivolt per division. So we have to switch between these two, okay, and we set the trace in the middle of the graticule for the 1 millivolt per division setting, and then we need to switch to our 2 millivolt per division, and then center that back on the middle of the graticule. Okay, and then we adjust it back. There we go. So we have no difference in the position from 1 millivolt to 2 millivolts. And then we go from 2 millivolts to 5 millivolts. Here we have a little balance potentiometer. This is the one you want to adjust for the channel 1. And there's one kind of hidden behind this rod for channel 2. So put your screwdriver in there, just like this. and we want to adjust it so between 2 and 5 there's no difference. And I'd say that's good enough. So we have 1, 2, 5. 1, 2, 5. Now we can sweep through the entire range, and it stays dead flat for all of those different settings. Like vintage Tektronix, I think I'm gonna put up some more videos, so it would be worth subscribing. Just a thought.